scientists pinpointed the oldest meteor crater ever found. When the space rock struck Australia 2.2 billion years ago, it ended a global ice age. There are 70,000 meteorites, pieces of debris from space objects that hit Earth, currently known to science. But only 190 of them left behind impact craters scientists could identify. According to a new study published in the journal Nature Communications, the oldest such impact site ever found is located in Western Australia, about 500 miles northeast of Perth. About 2.2 billion years ago, a massive meteorite left a crater 43 miles wide. Today, the dusty, red-hued site called Yarrabubba lacks a defined crater. It disappeared due to erosion and shifting tectonic plates. There is very little rock that outcrops at Yarrabubba, and most of it is stained red. Timmons Erickson, a scientist at the NASA Johnson Space Center and the lead author of the study. But the rocks created by the cataclysmic event remain. A small hill in the middle of the site, called Barlani Rock, is made entirely of rocks that formed under the intense heat and pressure of the meteorite's impact. By dating those rocks, Erickson and his co-authors were able to pinpoint the exact age of the Yarrabubba crater. Their results showed it's more than 200 million years older than any other crater scientists have found on Earth. The Yarrabubba site is in the outback of Western Australia. The closest town, Meekatharra, is about 40 miles away by gravel track. Erickson travelled there in 2014 and collected 200 pounds of rocks to study. To determine the age of those rocks, his team immersed the samples in water in their lab, then supercharged the liquid with 120,000 volts of electrical energy. The electricity split the rocks into microscopic grains of zircon and monazite. These minerals imbibe radioactive material like uranium, which allows scientists to date them. The analysis revealed that the Yarrabubba rocks are 2.229 billion years old, plus or minus 5 million years. The next oldest impact crater site on the planet is the giant Vredefort Dome in South Africa, which is 2.02 billion years old. After that is the Sudbury impact structure in Ontario, Canada, which is 1.85 billion years old. But the Yarrabubba crater's age isn't the only surprising part of the story, Erickson said. The impact also occurred during a very dramatic time in Earth's history, when the planet was transitioning towards something more comparable to today. According to the study, when the Yarrabubba meteor hit, it likely smacked into a giant ice sheet. That's because 2.2 billion years ago, the planet was at the end of an era of glaciation called a snowball Earth. Erickson's team simulated the effect a massive meteorite hitting an ice sheet, and found that such an impact could have released up to 100 billion tons of water vapor into the upper atmosphere. That infusion of water might have led Earth's atmosphere to trap more heat, warming the planet and ending the ice age, Erickson said. Water is a very efficient greenhouse gas, much more so than carbon dioxide, he added. The Yarrabubba meteor wasn't the only space rock that changed Earth's climate. The 6-mile-wide asteroid that struck Chicxulub, Mexico, 66 million years ago sparked wildfires that stretched for hundreds of miles, triggered a mile-high tsunami, and released billions of tons of sulfur into the atmosphere. That gaseous haze blocked the sun, cooling the Earth and dooming the dinosaurs. Acid rain and fallout from the impact also acidified the world's oceans in a flash, causing a mass marine extinction. The authors of the new study wrote that such extraterrestrial bombardment likely had major consequences for Earth's development throughout history, if the meteors hit certain parts of the planet. Oftentimes it seems that the impact has to hit the Earth in a spot that is fairly unique for it to dramatically modify Earth's climate, he said. For example, the spot on the Yucatan Peninsula where the Chicxulub impact occurred happened to have large salt and gypsum deposits, which released huge amounts of sulfur into the atmosphere, creating terrible acid rains.